Hello. Many RPGs have a concept of critical success or failure when you have to do certain checks. In D&D, for instance, it's often, but not always, rolling a natural 20 or a natural 1 on the die, respectively. The 5e system in Foundry communicates this information by changing the color of the roll result. Today, we'll be looking at how to achieve that in our own system. But first, I need to make a bunch of changes. As usual, this is going to be pretty specific to Feng Shui, but if you're in a hurry, please skip to the chapter I will link to in the description below. At the heart of the big change is a desire to have all task checks use the same message template, so let's start by building that. The main div will have the dice roll class so that we can borrow some of the styling from normal roll messages. I'm also adding my own classes to identify the message as a task check, and the message will be split in 3 sections. First, we have a title letting the user know the type of check this is. No need to wonder about variables just yet, I'll explain that in a moment. For some task checks, we can know the difficulty in advance, like in def checks or up checks, and when we do, I'd like to have the difficulty listed in the title. If the task check is an attack, we'll inject the weapon card partial so that the information is in one place. This will replace the attack roll template we built in the last video. That means that this template needs to have the weapon damage value as a data attribute somewhere. I'm going to put this into the weapon card partial, right there. The final part of our message is going to be the summary of the roll. Just like in a normal roll, I'm going to display the roll formula and the tooltip, which is the breakdown of the dice results. There are 3 important values in a Feng Shui task checks that I want to display in this template. The swerve, which is the result of the dice themselves, including the potential fortune die. The action result, which is the sum of the swerve, the action value, and any other modifiers. And if this check has a defined difficulty, the outcome, which is the action result minus the difficulty. Note that I'm storing all these values as data attributes, which I think is good practice for any piece of data you might one day want to retrieve from a chat message. If you remember the last video, I said we couldn't inject custom chat data in roll.toMessage. So I'm going to write my own roll2custom_message function. This is going to take a roll instance, a template, and an object storing any extra data we want to pass to handlebars. Speaking of which, let's build that template context. This will contain the roll instance, the tooltip, which we have to generate with the getTooltip function, and the data object that was passed to the function. After that, it's business as usual to create the chat message. In fact, I'll grab that from the attack function, which won't need that anymore. Next, some changes to the task check function are required. I'm going to add 3 parameters, one holding a string for the type of check being made, one for task check difficulty, and a data object for anything else the handlebars template might need, like weapon data for attack rolls. I'll add a constant holding the path to the task check template I created earlier. Small change to the impairment check. There are instances where actor data can be null, so I'll need to check that it isn't before trying to retrieve the impairment value. Now, if we send the message directly from this function, we can now use our roll2custom_message function. We can calculate the outcome here and there if required. Calculating the swerve is going to be a bit more complicated, so I'll make a separate function for it. The difficulty here resides in extracting the value from the dice rolls without the modifiers. I could make my life easier by taking the modifiers out of the formula, but where's the fun in that? This is also a good opportunity to take a closer look at how to extract info from a roll instance, which we'll need to do later in the video. A roll instance has a property called dice, which is an array of objects containing information about the dice rolled. Each element of the dice array represents one dice term in the roll formula. So for a task check with a fortune die, the array will have 3 elements. You can tell what kind of die it is by checking the faces properties, though that information isn't important to me here. What I do care about is the rolls array, which lists all the dice rolled for this term and the corresponding results. In order to calculate the swerve, I'll have to reduce each dice term to a single number, totting up the results. Because the rolls are object, I need to use the map function to extract the roll result. With that done, I can get the swerve by subtracting the second term from the first and adding the fortune die if there's any. Our task check function now modified, we have to update the places where it's called. Let's start with the def check, since it's an easy one to roll on the character sheet. With the changes we're making, the task check function is now suitable for def checks, so we can replace the existing code with a simple call to task check. I'm setting the actor data to null so that impairment isn't applied. It's cheating a bit, but that's okay for now. To get the task type, we'll do something slightly new. The template expects the strings to be already localized. In the language pack, I've set up a bunch of strings for the different check types, and in the config file, I've created a dictionary pointing to the string paths. In the dice.js file, I'll import the config file at the top, so I can fetch the right string for the def check. While we're on the topic of the config file, so far we've only used it to store localized string paths, but it can do more. For instance, we've got that number 4 seemingly coming out of nowhere in the difficulty for the def check. It's never good practice to have hard-coded numbers like that. So what we can do instead is store that number in a variable in our config object so that we can refer to it. After this little detour, I'm going to update the attack function so that it sends the message directly, passing the weapon as extra data and using the stat name as the check type. We just need to make some quick layout tweaks in CSS, and now we can test the new chat message, first with an attack, and then with a def check. Cool. This is all working fine. The changes I made broke a few things I need to fix, so let's do that before I forget. For task checks rolled from the character sheet, I need to specify the check type. I'll do this through a data attribute I'll call check type. In skills, the value of the check type will just be the name of the skill itself. In the character stat block, I'll use the name of the stat as a key to look up in the config dictionary for check types. It's basically the same thing we did for the def check, but from handlebars rather than JavaScript. I also need to change the selectors I'm looking for to determine what role can be defended against, and to retrieve the relevant information to do so. Okay, with the cleanup done, we can get to the video's main event. In case you lost the plot, the goal today is to alter the appearance of task checks that are critical failures, or potential critical successes. But since these are random by design, it wouldn't be a time-efficient testing strategy to keep rolling dice hoping we get the result we want. So we need to construct fake rolls that consistently give us the result we want. I create a macros.js file in which I'll import the functions from the dice file. In Fengtree, there are two ways for critical failures to happen, or way-awful failures as they are called in this system. The first one is by having a negative action result. This is pretty easy to manufacture. So I'll create a function called testNegativeActionResult, which is just going to call a task check with a very high negative action value. The second way to get a way-awful failure is by failing to meet the task difficulty, i.e. getting a negative outcome, after rolling boxcars. What Fengtree calls boxcars is when both your dice explode at least once. This means we need to build a dice roll with a specific result. The roll class gives us a function to construct a roll instance from a data object. For this data object, we need to define the class, the formula, the parts of the formula, which you can deduct from the formula, the total result, and the list of dice. For each dice, you need to specify the class, the number of faces, and list of rolls. We've seen how that looks like before. In this specific case, I need to add an exploded property to the first roll of each dice and set that to true. Once the data object is constructed, I can pass it to roll.fromData, which will return a corresponding roll instance. I can then create a task check message out of that. I can hardcode the swerve and the difficulty because I know what the result of the roll is. Now that our test functions are ready, we need a way to expose them to the console. There are many ways to do this, but I'll follow the pattern from DND5e. In the main system file, we're going to import all the functions from the macros file in a macros namespace. Then, in the init hook, we're going to create a game.fs2e object to store a bunch of things related to our system, one of which is going to be the macros namespace. Now, in Foundry, I can open the console and call, for instance, game.fs2e.macros.testNegativeActionResult, which will consistently give me a role I can do some tests on. If you don't want to be typing this every time you need to make a test, you can create a new macro, set its type to script, and paste the command in there. Congratulations, you've just learned how to make macros. Now that we can get way-awful failures on demand, let's see about highlighting them. In the render chat message hook, we'll call a function we're about to create called highlight task check results. Since this is called for every message in the chat log, we need to filter out messages that are irrelevant by testing that the message is indeed a role, that the current user can see its contents, and that it is a task check. The latter we'll verify by looking for a selector. Assuming the message passed all those tests, we'll grab the role from the message and dig in there to see if we rolled boxcars. If that's the case, we'll add a CSS class to the role formula element. Boxcars might be relevant for successes, that's why I'm highlighting them separately. Next, let's take a look at wayoful failures. If the role's total, aka the action result, is negative, this is for sure a wayoful failure, so we'll add a wayoful CSS class to the dice total elements. If the action result is positive, it might still be a failure if a difficulty was set for the task but not met while rolling boxcars. Finally, those newly created CSS classes need to do something. For the purpose of this video, I'll keep things simple. Wayoful results will be colored in red, the system's main color, and boxcars result will be colored in green. Now I can go in Foundry, use my handy macros to generate those test roles, and voila, our roles are highlighted. To be perfectly honest, we almost certainly could have achieved this by running similar checks when creating the message, and I'm not sure why the 5e system does it this way, but hey, we're here to learn and we've learned a new way of doing things. I'm not sure what the next video will be about, so it'll be a surprise. Bye!